Hello folks, thank you again for stopping by in our hybrid zombie shooter tutorial course. Now today is an exciting one because we're actually going to be making our gun fire, and also we're going to do a little bit of the aiming FOV functionality as well. Now this is a very long video, so I have decided to split this into two parts so you don't have to watch a 60-minute or a 70-minute video. I'm going to put it into two separate parts. In today's video, you will learn how to set up your FOV based on your weapons, your aiming status and your non-aiming status. And also we're going to do all the groundwork to set up our firing functionality. I hope you really enjoyed this, and I absolutely enjoyed making this video tutorial because I ran into a lot of obstacles trying to figure out some of these components, and I'm finally able to figure it out, and here I have it for you. So I would really appreciate it if you could hit that like button, and also maybe consider subscribing to the channel because a lot of work went into making this portion of the video. Thank you again for stopping by, and let's get into the video. Now the first thing that we want to do is to set up our input action. So I'm going to go to the content drawer, go to the third person folder, input action, and right click and create a new input action. Let's name this IA_fire. Let's go ahead and save all. Now open up your IMC default, and here add in a new mapping for the IA fire, and let's set this to the left mouse button, save it and close it. Now in our third person folder, we're going to go to our blueprint, third person character, and we're going to just right below where we're doing the sprint, we're just going to go ahead, right click and search for the IA fire, and this is going to be our input action event. Now, before we work on the fire function, I want to improve our aim down sight function. Now, our aim down sight right now just does the animation. It doesn't really have the camera zoom in on the player when they aim down sight. That's a normal for any type of shooter games. So we're going to take care of that really quickly. First, if you select our follow camera, our field of view is set to 90. So if I go ahead in game, I see that this is my 90 field of view. For your reference, that is the location and also the rotation of the camera at this time. If you select your field of view camera, and if you set this to, let's say, about 60, and if you press play, you can see how close the camera moves in onto the player. So this is exactly what we want to do, but we only want to do this field of view update when the player right clicks to aim down sight. So let's go ahead and take care of that. First, we need to determine the aim down sight based on our animation state that the player is in. So let's create a new function, and we're going to go ahead and name this get FOV per state. And this, we're going to go ahead and drag in our anim state, and we're going to do a select option. And we're going to create a new variable, and this is going to be our base FOV variable. And this, you can set it to a float. And when you compile, you should be able to set the value, and we're going to set it to 90. 90 is like a default standard value in the game industry. So we're just going to leave it at 90. And I'm going to drag in this base FOV and connect it to the unarmed. And also off of this base FOV, when I am armed with a rifle, I want the FOV to be a base. And then also when I'm armed with my pistol, I want the FOV to be a base. But when I aim with the pistol or the rifle, I want this to go down to like 60. 60 is a good number. And again, you can play with this as you see fit. And here I'm going to go ahead and do a return node. Drag and connect the return value to the return node. And this would be our FOV. We're going to name this new FOV. Compile, and let's make sure that this is a pure function. Compile and save. We can close this out. Now we're going to drag in our follow camera, and we're going to get our field of view. And we're also going to get our FOV per state. That's going to come out just as a value. So I want to get our current field of view, and I want the camera to move to our new field of view. And I want this to happen in a very smooth manner. So I'm going to use something called a f_interp2. This is a float interpolation node. So it's going to get your current float value, and then it's going to get your target float value, and it's going to move to that new target based on the delta time and the speed. Now the speed, I'm going to set this to 5. Again, play with the number. The higher it is, the faster it moves. And the delta time, we're just going to get our world delta seconds. So now, if I go ahead and drag in my follow camera, and if I set this up as our new field of view, this is only going to zoom in. That's because the f_interp node actually happens over a period of time. It's going to get our current FOV, and also our target FOV, and it's going to travel to it over a period of time. And this execution happens in an instant, so you will only be ever zooming in. If I were to press play, and if I get a weapon, and if I aim down sight, you'll see that every time I aim down, it's going to keep zooming in slowly. So we're going to need to do something for our game to set this function over a period of time. Timeline is a very good node to use. So the simple fix here is just to add a timeline in between and name this FOV timeline. And we don't want our player to zoom in and out for too long. So let's set the length to just 1 second and then just compile it. We don't need to do anything else inside of the timeline. And then just make sure that this plays actually from start. And now if I were to go in game, and again, only the aim down sight will only work if we're armed and aiming a weapon, because that's how we set it up. So in game, if I press 2 to grab my weapon, and if I right click, you should see that I'm aiming in. And when I stop aiming, it's going to go back to our previous FOV. This happens over a period of a second. So it has a really nice smooth transition. Now for our entire fire function, I wanted to have a crosshair. So I was searching through the Fab store to find a proper crosshair for our game, and I stumbled upon this amazing advanced crosshair system. Now this system is absolutely awesome. Kudos to CT Gaming for making this and also making it free for personal use. And I'm going to implement this into my game. This is going to save me tons of time, and it's a free asset. So if you're a beginner game developer, and if there are assets like this that are free and it's going to save you a lot of time, always jump on it. There are amazing assets like this out in the Fab store. Always feel free to look around it so you can find something that'll fit your game. So this system is pretty straightforward. You can just go ahead and add this to the project. I've already done so. If I go to my content drawer, and if I go open up our CT components, crosshair system components, it's going to have a blueprint class for our crosshair component. And then also in the demos folder and in the crosshair system, third person, it's going to have a weapons folder which contains all of the functionality. This crosshair system comes with a base weapon blueprint that is already multiplayer supported, and also has all of the shooting effects, 3 different types of weapons. It also has all the montages, also the animation blueprints. Everything is set up for you right here. Now, because I've already built the game from scratch, now I don't want to use everything from this pack, but I do want to move over some of the functions from this system to my game here, especially the weapon functionality and also the shooting effects and everything. I do want to move that over to my game because it's absolutely amazing how CT Games have done this. So I do want to credit them here and then also add those functions into my game. Now, this is a plug and play system, so you can simply download it and you can just insert it into your existing game if you haven't already done all of your animations and all of your functionality. But because I've already done all of that, I'm going to borrow some of the code from here. So let's go ahead and close this out, and I'm going to go ahead and recreate it. One of the other reasons that I want to recreate this as well is because of the interfaces. This system does not really use a lot of the interface functions, and I'm a huge fan of interfaces. It keeps the game running efficiently all the time. And if you want to just quickly implement this system into your game and start firing your weapon immediately, this would be the end of the video basically. But if you want to see how I implement this so that you can just run this without having to try to figure out how to implement that code into your game, then feel free to run along. Again, it is a quick plug and play system. I have played with it. It's very simple to set up. But if you do want to follow the code, let's continue on with the video. So the first thing I'm going to do is go into my third person folder, blueprints, and open up my third person character here. And then also go into my content drawer, core, interfaces, and then open up my BPI equipment interface. Now in this BPI equipment, I'm going to add in a new function, and this would be our trigger underscore fire. Now this function, I want to put it into a new category. This would be BPI, and then this would be our fire function. So this trigger fire is going to have 4 different inputs. And the first input is going to be our character mesh, which would be of type skeletal mesh component. The second one is going to be a start point, which would be of type transform. And the third one is going to be our player camera manager, which is going to be of type player camera manager, right? And the last one is going to be our triggered boolean with a question mark. So that's for your first function here. So I'm going to go to my third person character here, and I'm going to go and drag in our loadouts. And off of this loadout, I'm going to get our currently equipped weapon. And this, off of this equipped weapon, I'm going to call in our trigger fire message. Now, before we fire, we should check to see if the player should be allowed to fire. Because if the player doesn't have the weapon in their hand, then we should not allow the player to fire. If the player does have a weapon in their hand, and if they're aiming down sight, then we should allow them to fire. And certain weapons, if they're not aiming down sight, we should not allow them to fire. For example, if I pull out my pistol right now, I can see that the pistol is going to be down facing below, and it doesn't make sense for me to fire the weapon. But if I'm aiming down sight with my pistol, I should be able to fire. So let's go ahead and do a permission to fire function. So here in our functions, I'm going to go ahead and create a new function, and this would be permission to fire. This is going to be a very simple function. Let's go get our anim state. And we're going to do a select node in our anim state. And this is going to, we're going to set up a Boolean for this. And then the Boolean is going to determine if we're allowed to fire or not fire. So let's go ahead and create a new variable. And this would be granted. And that would be of type Boolean. Let's make sure that, let's go ahead and compile. And let's make sure that this granted is set to false. Drag this granted and connect this to unarmed. Again, this is a temporary Boolean. We're going to delete it in just a moment. And if the weapon is armed rifle, then we will allow the player to shoot because it's already in a firing state. If it is an armed pistol, like I mentioned, it's pointing down. We don't want them to fire. If they aim the pistol, we need to allow them to fire. If they aim with the rifle, they're granted to fire. Now, if I go ahead and delete this, I can maintain our Booleans. And unarmed, they're not allowed to fire if they are unarmed. We're going to go ahead and return this value. And this would be granted. Let's make this a pure function and then compile it. We can now close this function. In our event graph, let's go ahead and drag in our permission to fire and add in a Boolean and set this off of our triggered. When the player holds down the trigger button, if the weapon has the permission to fire, then we're going to go ahead and fire the weapon. And we're going to set this triggered to true. And to stop the fire, we're going to go to our BPI equipment and add in a new function, right? And then this is going to be stop fire. We're not going to have any inputs or anything like that. We're just going to set it to the fire category here, compile and save it. We're going to copy our BPC loadout and also the equip weapon here. And off of this, we're going to call in our stop fire message. Make sure it's a message. Connect this to canceled and also to completed. And now we need to determine all of these inputs for our trigger fire function. The character mesh is simply our mesh here. We're just going to drag and connect this mesh. Our player camera manager is basically if you right click and say get player camera manager, you're going to get the camera manager node. We're going to plug this in here just like so. And the starting point is more of a calculation based on the player camera manager location. So let's go ahead and get that. Let's create a new function, and this would be our get start point. This is going to be a pure function, so I'm just going to select it right off the get-go. Now, first, we're going to go ahead and get our player camera manager. And off of this, we're going to get our camera location. And we're going to get our camera rotation. And this location, we're going to go ahead and set this as a local variable. This will be local location connected here. And the rotation, we're going to again set this as a local variable, which will be our local rotation. Set this as a variable here. Now we're going to get in our local rotation. And we're going to go ahead and get our forward vector. And we're going to multiply this by our local location. And we're going to do a distance vector. And then this return value is what we're going to multiply by. And v2 should be our actor location, get actor location. And this, we're going to drag in our local location again, and we're going to go ahead and add it. Add this result here, just like so. And we're going to go ahead and make transform. This is going to be our location, and we're going to drag in our local rotation, and we're going to set this as our local rotation. Scale is going to be set to 1. And off of this set node here, we're just going to drag across, and then we're going to add in a return node. And this result, transform, is going to be our start point. Compile and save. So this is the calculation to determine our start point. So let's go ahead and close this out. And now drag in the start point and connect it to the start point right here. Compile and save. And now we're going to go ahead and add in that new crosshair component. So we're going to add in CMPT. If you search for CMPT, you should see that CT CMPT crosshair. So you can just plug that in here. Now this CMPT crosshair component actually has the crosshair show and hide function. So if you were to drag this component in, and if you search for crosshair, you have the hide crosshair and also the show crosshair. And it's a really good function. And I want to utilize this show crosshair whenever our weapon is out. And if our weapon is stowed away, then I want to hide the crosshair. Let's create a function to handle that. So this would be our crosshair underscore status. We're going to get our anim state. Again, it's so much easier to use our anim state. And we're going to do a select node. And we're going to use the Boolean. You see that granted Boolean? We're just going to plug it in here for now. And then again, we're going to get rid of it in just a second. So only when I'm unarmed, I don't want to see the crosshair. Everywhere else, I want to see the crosshair. So I'm going to go ahead and say true to all of this. Delete the granted and set this to false. Leave it at false. And this is going to be our return state. Add a return node. Plug this in here. And this would be, let's name this ch underscore status. Crosshair status. Compile and save. In the event graph, find the function where we actually set our current anim state. Here, we're going to go ahead and get our crosshair status, which is going to be of a pure function. Let's make sure it's a pure. Drag it in and set a Boolean. And set this to the branch here. Now drag in our crosshair component. And we're going to call in the show crosshairs. And then also we're going to get our hide crosshairs. And if the crosshair status is true, then we want to show the crosshair. And if the crosshair status is false, we want to hide the crosshair. This is all we're going to do. Compile and save. Now let's go ahead and test it in game. In game, I am unarmed, so no crosshair. If I press 1, I should see my weapon come out, and there is my crosshair. And if I aim down sight, I still have my crosshair. And if I press 2, I should pull out my rifle. I have the crosshair. I absolutely love the way that this crosshair functions with this download. It's amazing. All right, so let's go ahead and do our actual fire function in our weapon. So in our content drawer, we're going to go to our core folder, weapon system, blueprints, weapon base. So this is where a lot of the function is going to happen. And we're going to build, I'm basically taking the existing function and I'm stripping off all of the multiplayer component off of it. And I'm only going to keep the things that I believe are relevant to this game. Anything else extra, I'm going to get rid of it. That's one of the main reasons as to why I want to go ahead and build this on its own rather than just plugging in that component directly from the Fab store and trying to make it work with the game. In our weapon base, let's go ahead and open up our class settings and implement our BPI underscore equipment. And here we should have our fire and our equipment. We're going to use the fire function. So let's go ahead and set up our trigger and also our stop fire. Off of the event trigger fire, I'm going to drag this character mesh and promote it to a variable. Drag the start point, promote it to a variable. Drag the player camera manager, promote this to a variable. And this triggered, I'm going to go ahead and promote it to a variable. But before I connect this here directly, I'm going to go ahead and drag in this triggered. And I'm going to do a get and do a branch here. And connect this to the branch and connect the triggered here. If the triggered is set to true, we're going to do some functions here in just a moment. But if it's set to false, then let's go ahead and set it up again. And off of our event stop fire, we're going to go ahead and set our event trigger to false. This is basically to tell the game to stop firing. As long as the triggered condition is set to true, the game will continuously keep firing the weapon. And as soon as you release the button, we're going to go ahead and set the trigger to false, and this is how the game is going to stop firing. Now, off of false here, after we set the trigger, we're going to drag off of this, and we're going to search for a timer by function name. And here, the triggered is going to be in our looping, and our time is going to be a fire rate. So we haven't really determined the fire rate for our weapons, so we're going to go ahead and add that in really quickly. So get to our content drawer, core, weapons, weapon structure. We're going to add in a new variable and then name this fire rate and set this to a float and save it. Now we can close this structure. Let's go to our data table really quickly. Select our AR4 and I'm going to set the fire rate of the AR4 to 0.13. With testing, this number worked out very well, but in your game, feel free to increase or reduce the fire rate based on the weapons. And for the pistol, I'm going to set this to 0.6. Let's go ahead and save this. In our weapon base, we're going to go ahead and drag in our weapons info. And off of this, we're going to break it. And we can hide all the unconnected pins except for our fire rate. And we're going to just plug this into the time just like this. So now based on the weapon that we're holding, that fire rate is going to be different. And the return value of this, we're going to promote it to a variable. And this would be our fire rate timer handle. And also in our stop fire function, we want to drag this fire rate timer handle. And when we are stopping fire, we want to stop the timer as well, or a fire rate. So here we can just go ahead and invalidate clear and invalidate timer by handle. So this will stop that timer. The function name that we're going to actually run with this timer is going to be an ammo check. So let's create a function for that. So in our functions, we're going to create a new function for ammo check. The ammo check function is going to be pretty straightforward. We're going to drag in our weapons info and do a get. Off of this, we're going to break it. And we're going to only need our magazine size. Let's create a new variable, and this would be named ammo_used. And we're going to keep a track of how many bullets has been used. And then based on that, we're going to trigger a reload function or a fire function. So let's go ahead and get our ammo used. When the ammo check function triggers, we're going to go ahead and check to see if the ammo used is equal to our magazine size. And connect a branch here. And off of true, we want to go ahead and reload the weapon. And off of false, we want to increase our ammo used count and go ahead and fire the weapon. So for that, we're going to create two custom events and connect them here. In our event graph right below the stop fire, I'm going to go ahead and create a new custom event. And then this is going to be a reload event. Again, we're going to play some anim montages and stuff like that here, but we can take care of that later. At the same time, let's create a new custom event. And we're going to name this fire_weapon. And this is the function that we're going to call when there's enough ammo in. Off of true, let's call in our reload function. Off of false, we're going to do a increment integer. And this is going to be for our ammo used. This will increase our ammo used by 1. And after this, we're going to go ahead and fire our weapon. And that's it for the ammo check function. Now, as soon as the ammo use reaches our magazine size of that weapon, it's going to trigger a reload weapon function. And while we have ammo, we're going to go ahead and continuously keep firing. Now let's go ahead and take care of this in our event graph. I'm going to move this reload function a little bit lower so we can work on this fire weapon. In our fire weapon, we're going to drag in our character mesh first. And then off of this, we're going to go ahead and play a montage. Connect the character mesh to the in-skeletal mesh component. And here we want to play a fire animation. So we can add that to our structure as well. So let's get our S weapons info. Here we're going to add in a new variable. This is going to be our fire animation. And this would be of type anim montage. Object reference. Save. Let's open up our data table with our weapons detail. And then here for the fire animation, I'm going to select our retargeted rifle fire for this. And for the pistol, RTG pistol fire. Now in our weapon base, I'm going to drag in our weapons info. And here I'm going to break it. And we only need the fire animation here. So I'm going to plug that into our montage to play. And here we're going to go ahead and do a sequence node. Let's go ahead and open that up. And sequence node is going to run everything in our execution 0, followed by everything in our execution 1. So first, we're going to go ahead and add in a new variable, and this would be our line trace count. And let's set this line trace count to 1 and drag this line trace count in here. And we're going to go ahead and subtract 1. And off of then 0, we're going to do a for loop and connect this result here to the last index. And in this for loop, we're going to go ahead and create a new function to do our line trace. So it creates that straight line as to where we're going to fire. So in our functions, let's go ahead and create a new function for line trace. And this line trace is going to have an input of a start point. And that would be of type transform. And this line trace function is basically creating a line trace, right? So first we need to get a reference to our CrossHair component that we added to our player. So in my event begin play, I'm going to go ahead and get our player character. Off of this, I'm going to get the component by class. And this would be our CMPT CrossHair component. I'm going to drag off of this return value and I'm going to promote it to a variable. And this variable, we're going to name this as CTCMPT crosshair and set this as our variable here. Back in our line trace, we're going to go ahead and drag in our CTCMPT crosshair variable. And off of this, we're going to search for a line trace for objects. Connect this here. And our start point is basically this here. So the object type is basically what are the objects that we're looking for. So the objects that we want to see is basically the enemy player and also the world dynamics. So we're going to go ahead and make array here and add in 3 array item. First one is going to be the pawn. So this is going to be our enemies and stuff. Then our world static and also our world dynamic. These are the things that are in the world. And the actors to ignore, we can go ahead and make array here. And we're going to have 2 pins to the actors to ignore. One is going to be our owner of this weapon base. We can ignore that. And then also we can ignore self. And we're going to draw a debug line for now, just so that I can show you how this line trace works. And then we're going to do a return node here. And then connect this out hit directly to the return node. And name this as our hit result. Compile and save. Now we can go ahead and close out this line trace. In our event graph, let's go to our fire weapon function. And off of our loop body, we're going to go ahead and connect this to our line trace. And the start point is basically our variable start point that we have brought in earlier. Now this line trace is going to give us a result of everything that it's hitting. So I want to create a new function to manage everything that it's hitting. So I'm going to create a new function for this. And this is going to be manage hit result. And this is going to have a input of type hit result. And this is going to be of type hit result. It's a structure type. Compile and save it. Now in our manage hit result, we're going to go ahead and drag this hit result and then break the hit result here. And we are going to go ahead and create arrays. I can create arrays here, but I think it'll be better if I just keep it separate as a separate function. So I'm going to create a new array, and this would be manage arrays. This is going to have a impact point of type vector, impact normal of type vector, and also the type. And this would be our E_weapon type. Now this is something that I'm modifying this code so that it takes my weapon types into the game. So now in our manage hit result, I'm going to go ahead and drag this manage arrays in here and then plug this to the manage hit result. Off of our hit result, the impact point, I'm going to connect it here, and the impact normal connected in here. We can go ahead and minimize this, and then I'm going to drag in my weapons info and then break it. And here I'm going to hide all the unconnected pins except for the weapon type, and then plug this in here just like so. Compile and save it. Now in our manage arrays, we're going to go ahead and drag this impact point, promote it to a variable, and then immediately delete it. And then impact normal, promote it to a variable, immediately delete it. This will create 2 new variables. And both of these variables, we want to make this as a array. So we can go ahead and add more than 1 line items to it. So I'm going to drag this impact point and also the impact normal. And I'm going to do an add function, add the impact point here. So this is going to keep note of all the location where the bullet is hitting or the line trace is hitting, right? And the impact normal, same thing. We're going to go ahead and drag off of this and do an add function. And then we're going to connect this impact normal just by doing get impact normal. There you go. And then we're going to add in a small bit of a delay. So this gives enough time for the game to finish any of its processing. We don't want to overload it. So in our event graph, I'm going to create a new custom event. And this would be named as delay event. Now this delay event is basically going to have an input. And this would be our weapon type or type. And this is going to delay until next tick. And then it's going to handle all of the gun effects. So let's create a new function to handle all the gun effects. So handle gun effects. And after we delay this tick, we're going to call in this gun effects. And then we need the type in there. So add an input to our gun effects. And then this would be our type. And let's plug this in here, just like so. Delay is just to create some efficiency in processing all of this code that's going to happen within a frame or when we click a button. All right, so let's go ahead and handle our gun effects.